begin today, you guys. Let's take a look at what our Common Core is. So, complex number system. So, know there's a complex number I such that I squared equals -1, and every number has a form of a plus bi with a and b as real. So that is our Common Core, which is NCN1. So let's write that down. So we're going to go ahead and go NCN-1, and it says, again, know that there is a complex number I such that I squared equals -1. And it also talks about complex numbers, and we'll go complex numbers in the form of a plus bi. Okay, so in the reading, there it is, to find the number I. Well, the number I comes from this whole thing that I squared is equal to -1, so I is simply going to equal the square root of -1, okay? So we'll call that an imaginary number, right? That's an imaginary number. Imaginary number. Okay, I'll give you a second to catch up, okay? So back to our Common Core standard, NCI, which stands for the complex number system, and 1 because it talks about know that there is a complex number I such that I squared equals -1, and there's also complex numbers in the form of a plus bi, okay? Now, what's a complex number? There it is. It's an a plus bi. What does that mean? We have a real plus or minus some imaginary. So what we do is we get real numbers with imaginaries. As an example, let's say we got 2 plus 3i. That's my real number, the 2, and the 3i is my imaginary. So we can graph this as a point with the real numbers being the x-axis and my imaginaries as being the y-axis. But in this case now it's the I-axis and the r-axis for the reals, okay? So a point like this, 2, we'd go over 1, 2, and on the imaginaries, 1, 2, 3, we have a point right here. So this is a complex number because it has both a real and an imaginary. Alright, now let's go ahead and find if there's a pattern with imaginary numbers. Well, I squared, we already talked about I squared. There it is. I squared is equal to -1. I cubed there. Well, I cubed can be thought of as I squared times I, right? I squared times I is I cubed because I have the 1 power. We know I squared is equal to -1 times I, which we're going to keep it as I. We're not going to change the square root of -1. Just plain old I. So square root of I squared is -1 and I is I. So the answer to I cubed is a -1i or a -I. I to the 4th. Well, I to the 4th can be written as an I squared times an I squared. Alright, I squared we found out was -1 up here, so -1, and I squared is equal to -1. So -1 times -1 makes a positive 1. Weird. Imaginary numbers now becomes real. Wow, that kind of happens. And so what happens is you get a pattern. Every multiple 4 is a 1, and then you get something left over. So I to the 5th can be written as I to the 4th times I to the 1, which would be I to the 4th, we just found out I to the 4th is 1, I to the 4th is 1, times I, which is just I. Okay? And that pattern will repeat. Okay? Now, let's take a look at the notes. Okay, again, our Common Core standard NCN1, which has to do with numbers and our complex number system. Number 1 is just to know that there is a complex number I such that I squared is equal to negative 1. And there's a complex number, a plus bi. Okay, so there's my Common Core standard. Numbers, number sense, complex numbers 1. So we need to know that there is a complex number I such that I squared is equal to negative 1. And there's a complex number in the form of a plus bi, where a is my real and bi is my imaginary. Okay, so how do you deal with this? Well, these are actually pretty easy, and I believe you learned these last year, but let's take a look at it. Okay, so when we add real numbers with real numbers, and we add imaginaries to imaginaries, so we're going to add. This is plus, it's not FOIL. So 3 plus 4 is 7. 5i plus a negative 2i just makes a positive 3i. That's it. Done. Easy. Okay, example 2. We're just going to subtract. Reals with reals, imaginaries with imaginaries. Got to be careful of the double negative here. We're going to make sure we are careful of our double negative. So 3 plus 4 is 7. And 5 minus a negative 2. Now that's a 5i minus a negative 2i. The same thing as a plus. Gives me a positive 7. Oops, I made a mistake on this one. Darn me. 1, yeah, plus a 7i. There we go. Yeah, 3 minus 4 is a negative 1. Yeah, I hope so. Alright. Sorry about the mistakes, you guys. 3 is going to be a FOIL problem. So we'll multiply. 3 times 3 is 12. 3 times a negative 2i is a negative 6i. Because you can multiply, just like coefficients. 5i times 4 is a positive 20i. And 5i times negative 2i is a negative 10i squared. Okay, we're not done. A couple of things we can do. One of the things we're going to do is we're going to change this I squared. Okay, right here, this I squared we're going to change into negative 1, and we're going to combine these two. So, we're going to go 12 plus a 14i, and then we're going to go negative 10, and I squared is a negative 1, so we're going to change my I squared to negative 1, so we're going to multiply, okay? It's a negative 10 times negative 1. Okay, let's keep going. 12 plus 14i plus 10. Now we'll add the reals with the reals. So I have a 22 plus 14i. So the form should always be real plus imaginary. Remember in our reading, we always want it in the form of a plus bi. So we go the 22 plus 14i. Okay, example 4. Now I to the 23rd. It can be the same thing as I to the 4th times 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 I third. Okay, let's see. 1, 2, 3, 4, 5 of them. Now why would I want to do that? Well, I want to go I to the 4th, 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 I to the 3rd, right? Which I to the 4th is 1. So that means that's 1 times 1 times 1 times 1 times 1 times I to the 3rd. Now that's kind of doing it the long way. The way I would do it is say, wait a minute, what's a multiple of 4? So how about I to the 20th times I to the 3rd? That's faster. I mean, this is really kind of a pain. So I'm thinking, okay, what goes into it? A perfect multiple of 4. Okay, I know 4 goes into 20. So this becomes just 1 because this is all those I to the 4s. And then I get I to the 3rd. Well, what is I to the 3rd? I to the 3rd, we learned, was a negative I, and that was in our reading. So we'd have 1 times our negative I, which just makes negative I. Okay? Alright, so far, so good. Example 5. Now, there's a rule in math, just like square roots, where you can't have an I in the denominator. So, what we learned in square roots is you fix the problem with the problem. Well, our problem is the I. So what I'm going to need to do is I'm going to need to fix that by multiplying the problem. So I'm going to fix the problem with the problem. All right? So what am I going to do? I'm going to take and multiply both top and bottom here by I. Whoops, that's not the right color. Try it again. I want red. I over I. Okay, so I multiply by I over I because the problem is I. So if I multiply that, let's do it here. Let's go 7 plus 3i over 4i, and I'll multiply by I over I. Fix the problem with the problem. You can see that better. Good. So 7i plus a 3i squared over a 4i squared. Let's change the I squareds into -1. 7i plus 3 times -1 over 4 times -1. I squared is equal to -1. I'm going to get a -3 plus 7i over -4. Now I'm almost done. Can't really have this answer. It needs to be written as two separate numbers. So I'm going to change it to 3/4, because that's the -3 over 4, minus 7/4 I. Okay, that's the form it needs to be in. Real number plus imaginary. So let's back up. Couldn't have I in the bottom, right? So I multiply the problem with the problem. I fix the problem with the problem, multiply it by I over I. Got the I out of the bottom, out of the denominator, and there's my answer. Okay, number 6 is a little bit different. We're going to multiply by a thing called the conjugate. We did this in Algebra 2 with square roots, but we'll do it again. So the conjugate is like the opposite. Now again, there's an I in the bottom, but it's because of this minus. There's a plus or minus in between. We got to multiply by the conjugate. What is the conjugate? Well, the conjugate is 1. It's the opposite sign. Opposite sign. 1 plus 2i. So multiply top and bottom by a 1 plus 2i. Okay, how does that help you? Well, let's see. We need to get I out of the bottom. So I'm going to multiply. I'm going to FOIL. I'm going to go 3 plus 6i plus 5i plus 10i squared, because I times I is I squared, over, let's FOIL this, 1 plus 2i minus 2i minus 4i squared. Okay, still don't have I out of the bottom, or out of the denominator, but I'm getting closer, okay? So I'm going to do two things. One, I can see this and this. Those two cancel, right? I'm going to change my i's into -1s, okay? And I might as well combine those. Those can be combined. So let's see what I get. Those cancel because they're opposite. So I'm going to have a 3. 6i plus 5i makes an 11i, okay? Plus 10, and I squared is a -1 times -1. Okay, in the denominator, the two i's are gone. So I'll have a 1 minus a 4, and I'll make my I squared into a -1, okay? Alright, we're getting close. That's a -10, and that's a +5, so let's go 3 plus 11i minus 10 over 1 plus 4, because -4 times -1. Almost done. This is now going to be a -7 over 5 plus 11/5 I. Okay, here's my -7 over 5 plus 11/5 I. And there's my answer. Okay, let's turn the page. Alright, so here we go. This is what we're really trying to lead into, is trying to solve quadratics. So if I have to solve this, alright, let's just go ahead. Let's solve it. So x squared minus 9 minus 9, right? So x squared equals -9, because I go minus 9 minus 9, right? Two answers. I know two answers because of the x squared. So I'm going to take the square root. I'm going to have x equals plus or minus the square root of -9. Alright, I'm going to break this up. I'm going to have x equals plus or minus the square root of 9 times the square root of -1. Because 9 times -1 equals 9. But the main reason I'm going to do this is because this is my I. Here's my I. So I'm going to have x equals plus or minus 3i. Okay, that is two answers. It really is two answers, because my two answers are 3i and -3i. But it's so much easier just to write as plus or minus. Positive 3i and -3i. There's my two answers. Okay, example 8. Boy, if it factors, it'd be great. But if it doesn't factor, Then we have to use a quadratic formula. The poly button won't give me the answer I want. I'm going to have to use my quadratic formula. So what is a quadratic formula? Let's write it down. Quad formula. And I need you to use the quad formula because I need the exact answer. So it is negative b plus or minus square root b squared minus 4ac all over 2a. Okay, that's my quadratic formula, right? So in this example, there's my a is 4, b is negative 24, and c is 37. So let's plug it into the formula, okay? Negative b, so we're going to go negative 24. So I'm going to go minus negative 24 plus or minus the square root of b squared, which is a negative 24 squared, minus 4 times my a, which is 4, times my c, which is my 37, all over 2 times my a, which is 4. Alright, I'm going to need my calculator just to get some numbers here, but that's a positive 24, right? Double negative. Plus or minus the square root. Let's see, what is 24 squared? I don't know. 24 squared is 576. Okay, 24 squared minus 4 times 37, 592. All over 8. Okay, I'm getting there. So let me subtract these two. 576 minus 592 is negative 16. 24 plus or minus the square root of negative 16 all over 8. Now I already know I'm going to have imaginary numbers. So it's really going to be a complex number because I'm going to have a real. So I already know I'm going to have an I. There is going to be an I in this because of the negative. Okay, so let's do this. We're going to go 24 plus or minus 4i, right? Because the square root of 16 is 4 and the square root of negative 1 is I, all over 8. Now there are two answers, okay? Two answers. Let's figure it out. So we're going to have, scoot this up here, we're going to have a 24 plus 4i over 8, and we're going to have a 24 minus 4i all over 8. Okay, so let's break it up. We're going to have 3 plus a 1/2 I, and we'll have a 3 minus a 1/2 I. Those are the answers. Those are the answers. Me, I would write it like this. 3 plus or minus 1/2 I, because then it shows both at the same time. Okay, here is your homework. I need you to do it. I need you to work in class. When I get back, I'll stamp it, and then that will be that. All right.